Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaku. Now, finally, the day for S1 is just around the corner. And for S1, that is Probability and Statistics 1, we'll be having two sessions. One, you will see it recorded, and this is on Monday. And today, I think it's the 12th. So this is 12th of May 2025. And this is what you will see will be recorded version. And on Tuesday, that would be 13th of May 2025, you will see the live version on YouTube. Now, in these 2 days, we'll be focusing on the major topics of S1, almost all of the topics. And let me write it down. If I write on one side probability, so let me write over here probability, whether it's basic probability, whether it's probability distribution, whether it's binomial or geometric. This you can consider as one basic unit because it's all related with probability. This is probability, whether this is sample space diagram or it's about tree diagram or it's about conceptual probability, mutually exclusive, independent, things like that. So that is mutually exclusive, independent. Conditional probability, of course, that's also part and parcel of it. And so on. And then probability distribution, which we label as DRV. And it's part of DRV, that is binomial and geometric, and maybe a combination of both. So this is like one section. And then if I look at the other section is about normal distribution. It is about Perms and Coms, NPR, NCR. It's about diagrammatic representation of data, in which there are two things. The first one is about mean, standard deviation, variance, assumed mean. That is also known as coding. And then the diagrammatic part. So now the diagrams, what do they include? They include basic things such as bar chart, pie chart, histogram, cumulative frequency. And then what else can we add? We can add the concept of box plot. We can add the concept of stem plot, and so on. So these are the two major chunks. So I think let's get started in this manner. So I think let me do this thing today. And this one over here, that is day 1 of this S1 online workshop. And let me focus on this thing in day 1, and let me focus this thing on day 2. So now normal, permutation, combination, representation of data, whether it's about calculation based, whether it's about diagrammatic based. So now what the years that I like the most, that is one of the toughest year, that is year 2023. And I'll focus on May, June, 3 variants, that is 51, 52, and 53. I'll focus on October, November 3 variant. Of course, it's the same, 51, 52, 53. So I'll be highlighting the questions down over here, and then we can do a comparative analysis also. So I'll be doing some comparative analysis between the questions. And then I'll be doing what else? I'll be looking at the examiner report once again. So let's get started. And what we see over here is May-June 2023, variant 51. This question number 1, that is about coding. Question number 2, that is permutation combination. Question 3 is also the same. And question number 4 is normal distribution. Let's skip this one because this is for day 2. Let's skip this one. So 4 and 6 and 7 is skipped. So first 4 questions. So let me go to the first 4 questions. That's right over here. And this is a lot of scrolling over here. So May-June 2023, variant 51. Now let's look at question number 1. It says a summary of 50 values of X gave this information, where Q is a constant. Find the standard deviation. Given that sigma X is this, find the value of K. Now, whenever you see something like this, that means it's a question of coding. It's a question of assume mean. It's about mean. It's about standard deviation. And remember, standard deviation, it's square root of variance. Now, the very first thing that you should do is this thing. Just let the examiner know what is your y over here or some other variable. Let y is equals to x minus q. That means from each value of x, this q was subtracted in order to make it smaller. We are getting this as the summation of y, this as the summation of y square. And n is 50. So summation of y square, sub n is 50. Y bar, that is sigma y over n. And standard deviation square, which means variance of y, it is sigma y square over n minus y bar square. And that is this thing. Take care of the accuracy. So they are asking the standard deviation of x. Standard deviation of x and standard deviation of y is exactly the same thing. That comes out to be 9.42, correct to 3 significant figures. It is further given sigma x is this, find the value of q. So now this was also a nice question. That if they have given a sigma x, so sigma x is what? That is x bar. Divide x bar is sigma x over n, that is 57.3. Y bar is 14. So how are they related? They are related by that same equation which was there at the beginning. Y is equals to x minus q. So therefore, y bar is equals to x bar minus q. This is x bar. This is y bar. Therefore, that's the value of q, and that is the exact answer. So that is question number 1. We are revisiting every single question that is possible. So now, if I talk about May, June 2023, variant 51. So question number 1 was a nice question of coding, and then we saw 4 questions. So question number 1, question 2, question 3, question 4, these 4 were for May, June 2023, variant 51. Let me cut this and let me take it on this page. So that's right over here. That is the first thing. So now let's move ahead. Let's move to question number 2. It says, find the number of ways in which a committee of 6 people can be chosen. So underline this thing. That is the word chosen. From this word, you know that it's a question of combination. This is not permutation. And committee, team, delegation, because everyone in that committee is of equal level. So that is a chosen thing. That is combination. It's chosen from 6 men and 8 women if it must include 3 men and 3 women. So we need 6 and 8 women, but it should include 3 men and 3 women. So from 6, select 3. From 8, select 3. That is 6C3 and 8C3. Multiply it out. That is the exact answer. No need of rounding off. Please make sure that you don't lose marks on accuracy. If it's exact, there is no need of rounding off. If it's inexact, work in 4 significant figures. Final answer 3SF. Now let's look at this question. A different committee of 6 is to be chosen from 6 men and 8 women. 3 of the 6 men are brothers. Excuse me. Find the number of ways in which this committee can be chosen if there are no restrictions of the number of men and women. So now it's not about men and women. It's from the perspective of these 3 brothers. 3 of the 6 men are brothers. So 3 are over here. How many men were there? 6 men. So 3 are over here, 3 are left, along with 8 women. 3 plus 8 is 11. So now it's 3 versus 11. But it must include no more than 2 of the brothers. No more than 2 brothers means what? A maximum of 2 brothers. Let me write another statement. That is at most 2 brothers. So now it is all about English. And then I have done it in 2 ways. The first thing, it could be 0 brothers. That means the 6 should be from here because we need a total of 6. It could be 1 brother and 5 from here. It could be 2 brothers, 4 from here, at most of 2 brothers. So this is 3C0 into 11C6. Similarly, 3C1, 11C5. Similarly, 3C2, 11C4. Write down all the options, add it up. Again, this answer is exact. Don't round it off. Method number 2. What is method number 2? What is not supposed to be done? Calculate the number of ways of doing that. Not supposed to be done. That is, all 3 brothers are selected. So that is the opposite of 0, 1, and 2. So these 3 are selected, 3C3, and out of these 11, we are selecting 3. 3C3 into 11C3, subtracted from without any restriction, 6 out of 14, 14C6, 3003. So this answer is exactly the same. So question number 2 is done and dusted. Question number 2, it's about combination. And it's about some brothers thing. So just remember it with this thing. The coding question, that was about Q was unknown. Question number 3. Find the number of different arrangements of the 8 letters of the word cocoon. COCOONED. COCOONED. And this is permutation. Now, something important. When you are doing the analysis, so that analysis should be like this. Okay. Now, this is a question of permutation. That was about this brothers. That was special on it. And then, of course, we'll be moving to the next one. So let me write over here another box. That would be for something, May, June 2024. Let me first write it, because you already have the access to all the recordings and everything. So now the focus is on just finalizing the details. May, June 2023, variant 52. And maybe 4 questions over here. And then again over here, I was needing some more space. So let me just shift this thing up. And so that we can fit everything over here. And then maybe 4 questions. And then one other color. So this is May, June 2024, variant 53. And then I can draw a line in the middle. And then we can have the November thing also over here. So right now, let's focus on cocooned. Find the number of different arrangements of 8 letters of the word cocooned. So there are 2 C's. 3 O's, NED, altogether 8, that goes in the numerator, divided by 2 factorial for the 2 C's, 3 factorial for the 3 O's. Exact, leave it as it is. Find the number of different arrangements of the 8 letters of the word cocoon in which first is O and last is N. So first is O, this is fixed. Last is N, this is fixed. How many are left? 6. 6 factorial, 2 factorial for O's, 2 factorial for C's. That's the basic thing. So now there was something about fixing also. So question number 3, and then there is this part. Yes, this was the difficult part. It says, find the probability that a randomly chosen arrangement of the 8 letters of the word cocoon has all the 3 O's together, given that the 2 C's are next to each other for 3 marks. So when the word given is there, that means it's a question of conditional probability. So given, that is about conditional probability. Given that the 2 C's are next to each other, so this is the probability of given. The 2 C's are next to each other. They are in a box. 1, 2, 3, 4, 5, 6, 7, 7 factorial. Inside the box, 2 factorial divided by 3 factorial for the O's, divided by 2 factorial for the C's. That is this thing, 840. And what does it say? Now this thing is happening. We want the 3 O's together also. So this condition has to be fulfilled. So now 2 C's are there in a box. 3 O's are there in a box. 1, 2, 3, 4, 5. That is 5 factorial. What is happening inside the box? Nothing. What is happening inside the box? Nothing. There is nothing identical over here. Therefore, nothing over here. This comes out to be 120. It's asking for probability. So this is permutation and probability 1/7. This is conditional probability. So now let me write over here. In this cocoon, there was something about fixed. So let me write over here. In cocoon, there was something about fixed and something about conditional probability. So now you will remember that this question was slightly more difficult. The brothers one was still basic. Coding was basic, nothing special. Now let's move to question number 4. It says this thing. It's, let me get the highlighter. A mathematical puzzle is to be given to a large number of students. The times taken to complete the puzzle is normally distributed. This is the mean. This is the standard deviation. In a random sample of 250, how many would you expect to have taken more than 20 minutes to complete the puzzle? Now, when we talk about this thing, and they are saying expectation. So yes, it is normal distribution. And then when it's asked for expected value, that means you have to use the concept of NP, because basically what you are creating is a binomial. So we are using probability of success from normal. We are creating a binomial. We are calculating the expected value, which is NP. And then if it's about some fruit or people, so both options are possible. Round it down, that is also possible. Round it up, that is also possible. Now keep that in mind. Next time when you approach such a question, that is exactly what you're going to do. So now let's go ahead and check this out. In a random sample of 250 of the students, how many would you expect? So let me just go back. How many would you expect to have taken more than 20 minutes to complete the puzzle? So first of all, write down the distribution. So the distribution should be written down. Let me just change this color to white. And let me change this color to... Okay. So now over here, first of all, the distribution should be stated. It's normal. The parameters, mean and variance. So parameters, that means the things on which the distribution is dependent. So for normal, it's mean and variance. Mean is mu, variance is sigma square. Step 1, find the probability. So when we find the probability x greater than 20, we standardize, subtract the mean, divide by standard deviation, we get this value. The table is based upon less than. If it's greater than, then 1 minus 5 of this value. And for negative values, we know that use symmetry for negative values. And for range of values, there are 3 rules which you already know. So now go to the table, write down this value, make a bracket. Brackets are for free. You get this answer. If they were only asking for the final probability, so therefore I would write 1496, that would become 150, 0.150 if the question ends over here. But it does not end, it moves to step number 2. So now distribution y follows a binomial distribution, 250, this is the success. Expectation of y is NP, and it's about students. So therefore, you would either write 37 students or 37 students. Rounded down is also good. Rounded up is also good. If someone wants to do it by ratio, you are most welcome. Out of 1, that's the probability. Out of 250, that is the probability. Cross multiply. So cross multiply, and then you get this answer. So the arrow over here is not for multiplication. So over here, basically, it's going like this, and like this. And then you get this answer, the same as over there. And then round it down, round it up. So that is the analysis of 4 topics in one particular variant. All good, all clear? I won't go on the marks because the marks could vary from paper to paper. Now it's not over yet. There is also this normal approximation. So let's go over this normal approximation. Now over here, when we do the back solving thing, make sure the probability is at least 0.5. That means greater than or equal to 0.5. And then when z has a lesser sign, z value is positive. When z has a greater sign, z value is negative. It's the opposite thing of what our usual thinking process is. So now let me just look at the group. And over here, so now we are on May, June 2023, variant 51, first 4 questions. That is the analysis that we are doing. And we are moving forward in this direction. So AS2, AS1. Okay, now it says, no, this is not about normal approximation, my bad. This is about finding the value of mu and sigma, the simultaneous thing that comes. So this is that simultaneous equation kind of thing to find mu and sigma. So this is about back solving. So now over here, all the students are given a second puzzle to complete. Their times in minutes are normally distributed with mean mu, standard deviation sigma. It is found that 20% of the students have time less than 14.5 minutes. So 20% have time lesser than 14.5. This has to be fulfilled. Flip the inequality. So lesser becomes positive, greater, and subtract the probability from 1. For 80%, the z value is 0.842. So first thing first get rid of the table, use the table, and get this value straightened out. Similarly, 67% have times greater than 18.5. Greater than 18.5 is 67%. 67% is fulfilling this criteria. It remains as it is. Then, since this is greater, we know that z value is negative. This is greater. Again, z value is negative. The z value corresponding to 0.67 is 0.44. The z value corresponding to 0.80 is 0.842. Standardize, equate to this. Standardize, equate to this. You equate the z value with the z value. You never equate it to the probability. Keep that in mind. And then you form simultaneous equation, you sort it out, you find the value of mu, you find the value of sigma. So now this thing, normal distribution, it is about expected value, and it's also about simultaneous equation to find mu, to find sigma. So that was the first 4 questions of May, June 2023, variant 51. Now, let me just shift this thing a bit here. There's a lot of space. Let me shift it over here. And let's see how many questions are in the second variant. So that is the first one, the next one. Now, first one, this is geometric. Second one is a binomial, skip it. Binomial becoming normal. So yes, we can do this. Question 2. So let me just highlight these things. So question number 2, that can be adjusted. Let me make it thicker. That is normal approximation. Question 3, that is probability. We are not looking at this thing right now. This is a representation of data. So 2, 4. And then 2, 4, 6. That is normal again. Yeah, again normal. 2, 4, 6, and 7. That is permutation combination. So now let me go back. This is question 2, question 4, question 6, question 7. I think 2, 4, 6, 7, if I'm not mistaken. Yes. And then I'll write down something for each. So now, first of all, let's go over here. So now question number 2, this is about Anil is a candidate in an election. He received 40% of the votes. A random sample of 120 voters is chosen. Use an approximation. Find the probability that of the 120 voters between 36 and 54 inclusive voted for Anil. Now, the main things are already highlighted for you. The probability of success is 40%. That is the first thing. And the number of trials is 140. So that goes in the binomial bracket, the binomial distribution bracket, which is right over here. So first, whatever the original distribution is, state that thing. Use an approximation. So the only approximation, the only suitable approximation that we have studied is known as normal approximation to binomial. That means binomial becomes normal. So write down n. Let me highlight this. So write down the value of n and write down the value of p, and 1 minus q is 0.6. Evaluate np. Evaluate NQ, evaluate NPQ. All these 3 things needs to be evaluated. Then justify the approximation. So justification is necessary, whether the examiner asks for it or not. So always justify. So let me write over here, always justify the approximation. Since NP, this thing, since NP is greater than 5, since NQ is greater than 5, therefore X follows a normal distribution. This is the mean, this is the variance. So the mean is 48 and the variance is 28.8. And then it says it lies between 54 and 36 and 54 inclusive. So read it like this. X is greater than or equal to 36. X is lesser than or equal to 54. And then draw number line to show continuity correction. So over here, continuity correction, draw number line. Some people can easily do without it. I think it is preferable that you show it. So 36 is there, the boundaries are over here. 54 is there, the boundaries are over here. Greater than or equal to 36, choose the green one. Lesser than or equal to 54, choose the purple one. That's the green one, that is the purple one. Then standardize, use a calculator, write down the value. This is rule number 7. Z lies between two values. One is negative, one is positive. 5 of the first value plus 5 of the second value. Naturally, the minus sign is discarded. Add the probabilities and then subtract 1. And this answer give correct to 3 significant figures. So question number 2, that is normal approximation. Nothing special as such. So just let me write over here. That is normal approximation. Question number 2, that is stem plot with reasonings. So a lot of people, they ask questions about reasonings. Let me just double check one thing, whether the recording is all good, all clear. So now stem plot with reasonings. Let's move on. It says the times taken in minute to complete a cycle race by 19 cyclists from each of 2 clubs. Now, it's not necessary that the number should be the same. It could be different also. Cheetahs and panthers. So C on the left, P on the right. Find the median. It's already drawn. Find the median and interquartile range of the time of cheetahs. Usually, the examiner makes you work on the left-hand side block. Why? Because they just want to make sure that you do the counting right. 19 divided by 2, that is 9.5. Round it up. What do you get? You get 10th value. Therefore, the middle value is the 10th value. And lesser than the middle value, lesser than the median, is 9 values. The mid of those 9 values, which is the 5th value, that is the lower quartile, and similarly the upper quartile. So look at this. See for yourself. Can you locate the median? So the 9th value is 9/9, which is 99. And from the smaller 9 values, the middle value is 3/8, which is 38, which is not 38, which is 83. Because it's always from the stem towards the leaf. And the upper quartile is 6/10, which is 106. Therefore, the interquartile range is upper quartile minus lower quartile. And look at the key also. 7/9, 97. 9/1, 91. Left-hand side, start from the stem towards the left. Right-hand side, start from the stem towards the right. So always look at the key. Now it says the median and interquartile range for panthers is such and such respectively. Now it's a comparison. It's a comparison between the median of cheetahs and panthers. So cheetah is 99, panther is 103. And it's between interquartile range of cheetah, 23, interquartile range of panthers, that is 14. Make 2 comparisons between the times taken by cheetahs and the times taken by panthers. 2 marks, just read the thing. I want you to focus on the wordings. How have I used the wordings and everything? So now over here, when we use the comparison based on median, we use the following words. Let me highlight those words. Generally, typically, on average, when we are talking from the perspective of median, or maybe in some scenario, maybe we are talking from the perspective of mean. We will use these words. What does it say? The cyclists of cheetah teams are faster than cyclists of panthers on average. Why? Because the median of, I think this is panthers. So less time is faster. Keep that in mind. Less time is faster. So the cheetahs are faster than panthers on average. So when we use the word on average, the examiner will definitely know that we are making the comparison on the basis of median. Do not state the obvious. Do not say that the median is higher or this median is lower, nothing like that. The next one, that is based upon interquartile range. This is measures of spread, measure of dispersion, measure of variability. So now over here, maybe they can use interquartile range. Maybe they can use standard deviation or variance. So this is standard deviation or variance or interquartile range. They all are measure of spread and variability. So first of all, over here, this is 23, this is 14. So for the cheetahs, this is very high. For panthers, this is lower. Therefore, we would say the cyclist race time of Panthers Club is more consistent because low interquartile range as compared to the Cheetah Club. Or we can say this thing. Let me write at some place over here. Let me make over here. So whose time is more? That is for cheetahs. The cyclist time for cheetahs is more dispersed compared to the time for panthers. So when we use the word more dispersed, that means we are talking about higher interquartile range. Got the idea? Now, some other question, Yani, for the same thing, some other part. Another cyclist, Kenny, from the Cheetahs also took part in the race. The mean time taken by 20 cyclists was 99 minutes. Find the time taken by Kenny. That is basic O-level maths question. 20 into 99, that is 1980. That is the sum of all the time. Now add up all the score of the Cheetah Club. So now when I add up all the score of the Cheetah Club, sigma x is 1862. So basically we are adding these things. That is over here, 87, 78, 79, 80, 82, 83, 87, 88, 97, 98, 99, 101, 103, 103, 105, 106, 112, 118, 119, 124. So basically, you have to add all this up by converting it into the normal numbers. Now, once this is done, that comes out to be 1862. So 1862 and 1980, what is the difference? That is 118. That is the time for this new person, new cyclist in the Cheetahs team. His name is Kenny. All good. So now, that was a nice question. So let me write over here. So stem plot with reasonings. The reasonings were based upon median and interquartile range. And then there was a basic mean question also. So question number 6, now it's about normal distribution. Now what exactly normal distribution? Let's have a look. The mass of grapes sold per day by a large shop can be modeled by a normal distribution with mean 28 kg. On 10% of the days, less than 16 kg of grapes are sold. Find the standard deviation. Now, when probability is given, and you have to find either some X or some mu or some sigma or both, like we just saw in one of the simultaneous equation question. It's a question of back solving. Make sure probability is at least 50%. So now probability, let me write over here the word at least. So now probability X less than 16 is 10%, probability X greater than 16 is 90%. For 90%, a very famous probability, the Z value is 1.282. Now we do the standardization. Z is greater than this. Z is greater than this value with the negative sign. Compare the Z with the Z and you find the value of sigma, that is 9.36. That is the first part. The second part, the mass of grapes sold on any day is independent to the mass sold on any other day. 12 days are chosen at random. Find the probability less than 16 kg of grapes are sold on more than 2 of these 12 days. Now, from part A, we took the probability of success. That is less than 10 kg. So less than 16 kg. So less than 16 kg, this probability is 10%. And then number of trials is introduced. So now you created a binomial. This is not approximation. This is using the normal probability and more than one is there. So when we have more than 1 day, more than 1 day, whenever this is the scenario, you will create a binomial. So now Y follows a binomial distribution 12,10%. That is less than 16 kg of grape, less than 16 kg of grape. That is this 10%. More than 2, greater than 2, greater than or equal to 3. That is 3, 4, 5, 6, all the way 10 till 12. What we can do is that this is 3 all the way till 12. So what is left? 2, 1, and 0. Calculate these 3 probabilities according to the binomial and then write down the answer. Now, from the perspective of the examiner, make sure that you write this answer separately, this answer separately, this answer separately, or at least write them in a bracket and then add it all up in the calculator something. Write 1 minus this particular value, then subtract and then get the answer. First to 4 significant figures, then round off to 3 significant figures. So that is how this question is done. Not done. The third part. Now it says in a random sample of 365 days, how many days would you expect? So just like in the previous question, expectation. Again, this is binomial and we are finding the mean. The mass of grapes sold is to be within 1.3 standard deviations of the mean. So when we are talking about 1.3 standard deviations of the mean, that is mu plus 1.3 sigma, mu minus 1.3 sigma. And X lies between these two values. We just work with mu and sigma. Things would cancel out. No need to plug in any value. Mu cancels with mu cancels with mu, sigma divides with sigma, sigma divides with sigma. You get this and you get this. That is rule number 7. Apply, you get the probability. Don't stop, because now you need to find expectation. So W follows a binomial distribution. That is the number of days, number of trials. That's the probability of success. Find the expected value, round it up, round it down. Both are acceptable. This answer is coming out to be this, but it's number of days, round it up, round it down. So now this thing is done. Let me just remove the extra blank pages from here. So over here, that's over here. Okay. So now let me write it over here. Normal distribution. There were 3 things in normal distribution. There was basic. Then there was, let me just go back. First of all, this is within this thing. This is expected value. This was back solving. So that basic is basically back solving. Then the next part was expected value. And this is within 1.3 standard deviation of the mean. Now, let me explain one thing on the next page. Hold for a second. When they are asking about all these things, so there are different ways of asking it. Let me make it thinner. Let me write 3-4 different options. Now over here, if they are asking us within, let me just grab a normal distribution thing. And I think this is better to give you the view. And let me just focus on this thing because it hasn't come in a long while, so very high chances. Now, let me write over here, this is mu, and this is mu plus sigma, mu minus sigma. And I'm interested in this probability. Let me write another one. This is mu. This is mu plus 2 sigma. This is mu minus 2 sigma. I'm interested in this probability. Let me write over here mu. Let me write over here mu plus 1.5 sigma, mu minus 1.5 sigma. This is a little bit displaced. Okay, and let me just settle this thing. Now, let's do 3 examples over here. X follows a normal distribution, mu comma sigma square. And if I'm asking, find the probability X lies within one standard deviation of the mean. So that is mu plus sigma, mu minus sigma. When we standardize it, Z lies between mu plus sigma minus mu divided by sigma. This is mu minus sigma minus mu divided by sigma. So this is probability Z lies between -1 and +1. So whatever is the coefficient, let me make it thinner. Whatever is the coefficient of sigma, that will come over here. This is 1, this is -1. So therefore, this is phi of 1 plus phi of 1 minus 1. 0.8413 plus 0.8413 minus 1. And then you get this answer, 0.68 something. Okay? 6826, 0.6826. Let me just use a calculator. This is, I'm writing from my memory. So therefore, this is 2 times 0.8413. Yes, 0.6826, that is the answer. Now, for example, if I talk about the blue one, now the coefficient is +2 and -2. So probability X lies between mu plus 2 sigma and mu minus 2 sigma. When you do the simplification, Z would lie between 2 and -2. So now it would be phi of 2 plus phi of 2 minus 1. And I think this is 0.9972 plus 0.9972 minus 1. This is 0.9544. Again, from memory, let me just double check. So this is 0.9972 into 2. No, 9772. 9772. So this is 9772, 9772. So 2 into 9772 minus 1. I wrote it again. 9772 into 2. Yeah, 9544. 9544. And similarly over here, the coefficient is 1.5, 1.5. So probability X lies between mu plus 1.5 sigma, just like 1.3 sigma, mu minus 1.5 sigma. So therefore, Z would lie between negative 1.5, positive 1.5, that is phi of 1.5 plus phi of 1.5 minus 1, and then you get this answer. So that's how this question is done. So it was this thing after a long time. So this is important. Go over this. Now let's go to question number 7. And this one was normal approximation. This one was the standard deviation thing. Now, this time the word is Casablanca. So this is Casablanca. Now this is the word that we are using. What does it say? Find the number of different arrangements of the 10 letters of the word Casablanca in which the two C's are not together. So one thing is the two C's are together and then subtract. The second method is this thing. The two C's are separated. So we have 4 A's, we have SBLN. How many options are there for the blank spaces? That is 9. So there are 9 blank options. We can fit in 2. The two C's are identical. Divide by 2 factorial. What about these 8? They can be arranged in 8 factorial ways, divided by 4 factorial for the A's. And then you write down the answer. Now the next one. Find the number of different arrangements. Arrangements is permutation. So arrangement is permutation. A is permutation. B is permutation. C is selection. Okay. So it's a combination of first NPR. There are 2 parts, and NCR, there is 1 part. So 1 part, 2 part, 3rd part. That is 3 and 3 and 3, 9 marks. Now it says, find the number of different arrangements of the 10 letters of the word Casablanca, which have an A at the beginning and A at the end, and exactly 3 letters between the 2 C's. So A at the beginning, A at the end, this is fixed. And then 3 letters between the 2 C's. So that means the first time C would appear, that is the second one. Different options are there. Then 3 letters in between, then a C. So now this is second position, this is 5th. What about this is 3rd position, this is 6th. What about this is 4th position, this is 7th. What about this is the 2nd position, and then 3rd, and then 4th, and then 5th. And then 6. So this is 6th, 7th, 8th, and 9. There are 4 possible positions that are there. So now 4 times front and end, that's 1 and 1. The C's are also fixed. So let me write over here. The C's are also fixed. They are not moving at all. So this thing is there. And let me just write this thing in blue color. So that thing is there. And what about the blue is for the C's? My bad. So color. Okay. And then the C's are also fixed. So this C is fixed. This C is fixed. This C is fixed. C is fixed. Front and end. That is your A. That is fixed. This 4 over here is 4 possible options using a diagram. And then over here, 1, 2, 3, 4, 5, 6. That is 6 factorial, but there are 2 A's over here because we have used 2 A's. And altogether, there were 4 A's, so 2 A's are left. So 4 into 720 over 2, that comes out to be 1440, which is an exact value. So this is like permutation in which a little bit of diagram was kind of necessary. Maybe there are some geniuses out there who can do it without a diagram, but for the normal common people, a diagram was a must. Now over here, 5 letters are selected from the 10 letters of the word Casablanca. Find the number of different selections. Now, the rule is a lot of people, they ask this question whenever it's about identical objects, identical alphabets, identical letters, whenever this is the scenario, and select required and discard the rest. That is the rule. And when it's about identical and we are talking about selections, that is the rule. And if it's about identical and it's about probability, and very recently they asked about percentage, which is another name for probability. So now over here, when we are coming across this scenario, treat it like non-identical or different. And one of the best questions that I have done in this regard, that I just shared that video also with you. I think that was 2021. So I think the S1 past papers 2021, I think. And if I'm not mistaken, I'll just share with you the image. Somewhere over here, I think it's June or November. I'm not very sure about that. This question, that's right over here. So this question, check out the tomorrow question. This is May, June 2021, variant 52. Just go and watch this particular video. There was a video on the single question, and I gave example of this dollar bill. What is the difference if it's about probability versus it's about selection? So over here, it's about selection. Find the number of different selections in which the 5 letters include at least 2A and at most 1A. There are 4 A's altogether. At least 2 means 2, 3, 4. At most 1 means maximum of 1. Least could be 0. So just write down all the possible options. Keep this fixed 2. So this is 0 and 1. Keep this fixed 3, 0 and 1. Keep this fixed 4, 0 and 1. You need a total of 5. So 2 plus 0 is 2. You need 3 from these 4. 2 plus 1 is 3. You need 2 from here. 3 plus 0 is 3. You need 2 from here. 3 plus 1 is 4. You need 1 from here. 4 plus 0 is 4. You need 1 from here. 4 plus 1 is 5. You need 0 from here. So now when I select 2 A's, I discard the rest. If I select 0 C's, I discard the rest. If I select 1 C, I discard the rest. So all the selection is just based upon these 4 things. Of course, after taking care of all the possible options, that is how you do the working. Got the idea? So now this thing is done. So let me go back over here. And where is that page? Over here. So this thing, the Casablanca, and this was about 2 parts NPR, 1 parts NCR, and this is selection from identical thing. And over here in NPR, a diagram was necessary in one of the parts. Now, this thing that I have made over here so far, take a screenshot, and that is how you should study. You should study from the papers that you have already solved. And then based upon that, divide it into these 2 categories. Probability, probability distribution, binomial, geometric, that is 1 category. Normal, that includes normal approximation to binomial. NCR, NPR, representation of data, that is the other category, and that is how you study. So now let me do one more chapter, one more paper, 1, 2, 3. May, June 2023, variant 53. Question 1, skip. Question 2, haven't we done this? This is May, June 2023. Anil, no. This is not done. Question number 2, that is approximation. Question number, cheetahs and panthers. How can it's the same thing? Maybe I mixed up the two things. Hold for a second. The first one was the skew. Or maybe I've done all the three parts. Hold for a second, hold for a second. The cheetahs and panthers, variant 51, that is cocooned. Variant 52, that is Casablanca. And maybe by mistake, I think I did one question in the different order. This is, yes, we just did this. Cocooned is there. So maybe, achha, this is 51, my bad. 51, 52, 53. November. Cheetahs and panthers. That is 53. No, now this is different. Okay. Question number 1. Question number 2 is about Anil. Question number 4 is about cheetahs and panthers. Question number 5, this we skipped. Question number 6, that is the grape thing. Casablanca. So we just did this thing. Maybe I missed out 52. Yes, I think I missed this out. So that is 53 that we did. Now this is 52. So that was 53. Let me just do the correction over there. So hold for a second. Let me remove this thing. And by mistake, we did 53 first. So no issue. So now let's do 52. Question number 3 is stem plot. Box and whisker plot. That's question 3. Question 5 is normal. So question 3 is stem plot. Question 5 is normal. And first, let me note down. There is also approximation. Question 6 is combination and permutation. Question number 6 is combination and permutation. Question number, I think there are 6 questions in this one. Okay, so let me just remove the blank things. I'm just also waiting for Azan. This is probability that will come later. this is probability continued. This is expectation and variance. Okay, so let's just 1, 2, 3, 4. Okay. So now let's look at this question. Just read the question first. So it says the following back-to-back stem plot, stem and leaf diagram, that's another name for stem plot, represents the monthly salaries in dollars of 27 employees at each of the two companies. First, look at the key, 1/27/6. So 27 and then 1, you add a 0, 2710 for the company A, 27/6, 2760 for company B. So basically just add a 0 at the end. Then the first part is the basic thing. I'll just skip that one. That is the median, the lower quartile, and the upper quartile. And then the second part, let me focus on this. It says this is the 5-point summary. So for A, we have the lowest value, lower quartile, median, upper quartile, and highest value. For B, the same 5 things over here. Q1, Q2, Q3, that's given over here. Draw 2 box and whisker plot in a single diagram to represent the information for the salaries of employees at company A and B. For box plot, it's necessary that you draw the x-axis like a grid something. So let me just draw it properly. And then what else is there? The thickness doesn't make a difference, but whatever the thickness is, that should be the same for both the boxes. So mark down the 5 pointers, the lowest value, lower quartile, median, upper quartile, and highest value. And out of these 3, make a box. That is for the median. The same goes for B. Doesn't make a difference which one is at the bottom, which one is at the top. And try to fill up 3/4 of the space. And make sure that the scale is easy to read. The lowest value is 2540, 2500 actually. Highest value is 3090, 3100. So 2400, 2500, 26, 27. That's very easy to read. Comment on the mean would be a more appropriate measure than median for comparing the given information. Now, mean is distorted by extreme values. Therefore, median is a more appropriate measure for central tendency. So now look at the data. The data was revolved around here, and suddenly you get an extreme value. And over here, this is still spread out, but again, some extreme values are over here. So therefore, median is the best measure of central tendency. This thing is done. Question number 5, that is normal distribution. Have a good look at the first question. The length of Western bluebirds are normally distributed. The mean and standard deviation is given. A random sample of 150 of these birds is selected. How many of the 150 birds would you expect to have length between 15.4 and 16.8? Very simple. W lies between these two values. Standardize them. One value is negative, one value is positive. That is rule number 7. Find the probability, and then it's about expectation. So NP is there. So let me pause the recording. So now, when they are asking for expectation, so that is a binomial introduced, that is the number of trials, that's the probability of success, which is over here. And use the unrounded value. And then 2 options are possible, round up, round down. Both are possible. Even if you use the rounded value, still you would have an option of rounding up, rounding down. The lengths of eastern bluebirds are normally distributed with mean 18.4, standard deviation unknown, sigma. It is known that 72% have length greater than 17.1. X greater than 17.1 is 72%. Back solving using probability to find the z value. Since it's greater, z value will be negative. 72% is giving me this z value, 0.583. Standardize, equate it to negative 0.583. The value of sigma is there. By mistake, if someone took it to be positive, sigma will come out to be negative, which is not possible, but be very, very alert. The next one, normal approximation to binomial. A random sample of 120 eastern bluebirds is chosen. Use an approximation, find the probability fewer than 80 of these 120 have length greater than 17.1. So the probability of success was there from normal distribution. This is N, this is P, this is Q. Calculate NP, which is the mean. Calculate NPQ, which is the variance. Calculate NQ, which is 33.6. Justify, since NP and NQ is greater than 5, therefore Y follows a normal distribution. That is mean, that is variance. That is mean, that is variance. Lesser than 80, 80 cannot be used. Use either one of the two boundaries. Since it's not inclusive, therefore choose this boundary, which is not passing on top of 80. 79.5, standardize, negative 1.403. Z lesser than a negative value, use symmetry. Therefore, that is the same thing as Z greater than a positive value, which is 1 minus 5 of this value. 5 mean probability Z lesser than something. Read from the table, subtract, give the answer correct to 3 significant figures. Now, this question, that is permutation. In a group of 25 people, there are 6 swimmers, 8 cyclists, 11 runners. Each person competes in only one of these sports. A team of 7 is to be selected from these 25. Find the number of different ways in which the team of 7 can be chosen if it consists of exactly 1 swimmer, at least 4 cyclists, at most 2 runners. So 7 is there. 1, 4, 2. That is one option. 1, 4, 2. That is exactly 7. Now, this is exact for the swimmer, but at least 4 cyclists, it can become 4, it can become 5, it can become 6. Similarly, at most 2, maximum of 2, so it could become 2, 1, and 0. So if I increase from 4 to 5, I decrease from 2 to 1. If I increase from 4 to 6, addition of 2, then I decrease from 2 to 0. And then we write down all the possibilities. I think I forgot to write the multiplication sign over here. So therefore, this is multiply, 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 multiply. And there were 3 answers. Add them all. And that is this thing. That answer is exact. No need of rounding off. For another competition, it says a team of 9 consists of 2 swimmers, 3 cyclists, and 4 runners. So now combination is done. The first part is combination. Now it's permutation because it's asking for arrangement. They line up for a photograph. There are 9 people. If the swimmers stand together, so the 2 swimmers are in a box. Cyclists, 3 cyclists in a box. 4 runners in a box. So 2 factorial for this, 3 factorial for this, 4 factorial for this, and the boxes, their position can also alternate. So there are 3 boxes like A, B, C. In how many ways can it be arranged? 3 factorial ways. Again, exact, do not round off. How many different arrangements are there of 9 people if none of the cyclists stand next to each other? There are 3 cyclists, the blank concept, the space concept. So therefore, the space concept, the blank spaces for 3 things. So therefore, 1, 2, 3, 4, 5, 6, 7. There are 7 positions into 6 factorial for these ones. And this thing, this cannot be done without restriction minus together. So for 3 objects separated, that can be done by space concept only. It cannot be done with the subtraction thing because that is only applicable for 2 things. So if it was 2 objects not together, means the same thing as separated. So for 2 objects only, not together is the same thing as separated. For more than 2 objects, you have to treat it separately. So I think that is quite a comprehensive overview of these 4 topics. And this thing, let me just write it over here. This thing was about that swimmer and cyclist and runner and the arrangement. So NPR, NCR, both things were there. Normal distribution, that was basic. There was this basic has that expectation thing also. And then there was this approximation also. And there was this back solving also. So everything was asked over here. Now have a good look at it. That is the thing that is needed for you to go over the things and make sure you understand it very well. Break out things in this manner, as I've done for May, June. Try doing it for October, November, and then you're all set for tomorrow. So tomorrow we have a live class on YouTube. Inshallah, see you all there. Take care, everyone.